So, hello everybody. Let's start. We don't have time. Short introduction. Like you see, I'm sitting here alone. Somehow we both ended up as speakers, but we only have 10 minutes, so we have to cut it short. Don't worry, he still got his bottle, so we are safe, and my performance review too. A little bit to my background. I'm coming from a completely different industry. I'm actually worked for a long time in industrial automation. And fun fact about me is that I started using Kubernetes on bare metal before I ever used it in the cloud. Then I went a little bit to the cloud, back to Edge, and yeah, maybe at some point I will work on more cloud stuff. We will see. I have to introduce a little bit, at least the company I'm working for, or it's actually a group. It's more complicated. So it's a mysterious Schwarz Group. So most of you probably know us for our retail brands, Lidl and Kaufland. We are quite big. I think we are Europe's biggest retailer, actually. But there's way more than that. So we actually have a really huge production line, production plant. So we're producing a lot of the food we are selling ourselves. This is relevant because a lot of edge computing, interesting. Another big topic is recycling. So we're trying to close the circle, like you can see here. So the company that is there involved, PreZero, is actually the biggest recycling company in the world, which I think is huge. So nevertheless, all of this needs a lot of IT. So there's another one just called Schwarz Digits, and in this one, then we have the STACKIT, and this is for what I work for. Now we know the whole story. So edge computing. This is why I wanted to introduce this. So we actually have a lot of edge computing. Actually, that was the reason why I joined the company back in the days, because I wanted to work more in the field, and they promised me a green field. I can do a lot of stuff. Guess what? It's not a green field. So you would be surprised how much IT we actually have in the stores already. There are different systems running there. Self-checkout is a huge thing coming in more and more stores. So we have a lot of processing there, so we need compute. Waste separation, sorting out batteries and this kind of stuff. Logistics, obviously, or running AI models in the production to sort out bakery stuff, as an example. So a lot of different edge computing cases. And we wanted to unify it because we had, a lot of different solutions running everywhere, and we are still in the transition, but we have the goal to basically help the rest of the group to use a unified solution and don't reinvent the wheel a few hundred times, if this is enough. So we talk a lot about cloud all the time, and I mean, TalosCon, or at least edge computing, gets some spotlight. Cloud is sometimes simply not enough, at least not how we define it. So for us, for example, autonomy of our edge location is crucial. So we are running, in most of the cases, the control planes really in the edge locations. So it's easier to retain power than connectivity, for example. And this is our biggest goal, and was always the driver. We want to be as autonomous as possible. So latency, data locality, okay, this is a given one. Makes a lot of sense if you have to process something fast, if you don't have to send it around. And sometimes you really don't have good connections. So network bandwidth is a problem. Another good topic is improved security, especially when you talk about data privacy too. All data that you don't have to transport somewhere is definitely at a better place, so you can't lose it so easily. So it's another interesting fun fact where it actually helps. So this leads us then to what we call the cloud edge continuum, because we're trying to bring this all together. At the end, we want to have cloud-like environments everywhere. So for stuff that runs in the cloud or it runs on edge, we want to have a similar experience for our users. And this is basically what we call then the edge cloud continuum. What means this then for STACKIT? Quite obvious, we have a general purpose private cloud, focus of sovereignty. So this is this part, but another one that is more and more important for us is distributed cloud. Don't have the time to go really deep into that. It's basically core is more like complete data centers. Fog, we are talking more about relocatable stuff. So really stuff that are in boxes, for example. And for us, at least, edge is stuff that gets even smaller, so directly at the production belt. But we have to manage it somehow, and this is normally done by the other three. The other ones are basically self-contained. So how do we do it? How I like to put it, and I know it's not fully correct, but I have seen it here before, like Garrett, I think, called it like this too. From my definition, I see the whole Kubernetes, especially with Talos, more as the whole operating system. So I don't want to care so much about this layer. Like I said, different background. I built embedded Linux systems for 10 years and longer. I'm really sick of it. I don't want to do it anymore. I've seen everything, make monsters, big build systems like Yocto. They're all great. It makes sense why they exist. I'm sick of it. I don't want to do this anymore. I'm happy that Talos exists. I love it. And it does exactly what I want. It's small, it is declarative, and I really love it. How we're managing the whole thing, we're not using Omni, several reasons. We can discuss it afterwards. We have an own management plane that we're using for this. It's all based on Kubernetes, so like you can see, we are really heavily invested there. It's basically a bunch of operators, how we manage the whole zoo, and have like a fleet management really on big scale, because you can imagine there are really a lot of edge locations. The more independent stuff, so that is not connected to the cloud, gets a little bit more complicated, because then we really have to ship a lot of stuff ourselves. So this is what we then call more the distributed cloud, so it's way more independent and autonomous. Again, Kubernetes as operating system. Again, we are using their Talos, so we're running bare metal Kubernetes because it makes simple sense for us to build up the clusters like this. We have an EAS layer that we're using KubeVirt, even this is not a big surprise. Cilium and storage. Storage is an interesting topic, especially if you want to be in a sovereign space. There is not so many solutions out there that are really scaling and big and having really the performance. So we are going there with Ceph. And on top of this, surprise, surprise, then we see suddenly a Gardener symbol. STACKIT is really invested into Gardener, so we're using hosted control planes there. So even though I would love it with Talos, maybe at some point will, or Talos support for Gardener, whoever wants to join me, is still one of my dreams. But still, the hosted control plane feature of Gardener is really a big thing for us and really helps us there a lot. To manage now this distributed part, again, Kubernetes, right? We're using Kubernetes resource model. We are working with technologies like KCP, for example. If you've never heard of it, great project, really love it too. Really great and goes in a really good direction. And this gives us really the opportunity to fully manage it in a Kubernetes-like way, declarative, which I'm really obsessed with, and then really having a really good controllable system. So, like I said before, declarative by design. If you have something like this in a distributed way, and maybe you want to give it even to other people to operate, it's really important that you are able to ship something and you know what you're shipping. And this is where a little bit the cloud and the, let's say, air-gapped edge world is not so compatible anymore, because you need to know exactly what you're shipping and you need to be able to transport it. And you need to do this in a declarative way, because otherwise you don't get ever this complexity together. So even in this again, RP first design of Talos, and even this declarative approach that they have, perfect fit for our use case. This is why we love it. So another point that's really important for me, so I see Talos really as the operating system for Kubernetes. And I love Talos. I think I made it really clear here. Talos is awesome. And what we would like is, we would like to connect with more parties, even here in Europe, and to build more community, to make it bigger, and maybe contribute more into Talos, because we have a lot of people using it here. Still, I think most work, undoubtedly, is done by Sidero, which is great, but I think we can do all more, and I would really encourage other ones join us. We want to build a community, want to make it bigger. We don't know yet how, open for ideas, but this is basically the invite to everybody here to work further and make this even bigger than it is nowadays. And 9 seconds. Phew. Good. Thank you.